Avançado, aula 18, reading passage, Is the Earth Getting Warmer? Hello again, Carol, Erika.
Hello, how are you?
Hello, Mario. I'm still doing well. I was just
great.
eat some snacks, okay?
Oh, delicious.
Some tortillas, okay?
Wow.
Yes, something light before going to bed. Otherwise, I can't sleep.
No bread.
Yes, yeah, no, it's not time. Just the tortilla is fine, okay? All right, where's everybody? Only you guys. Okay. Well, the class is always on time, so we can start the class. They are late. Okay, there's one more.
Private classes.
Okay. Okay, Claude is here, Tiago is here, so we can start. Anyway, we were talking about global warming yesterday, okay? And we heard a passage concerning this, if the earth is really getting warming, okay?
Yeah.
So as we heard yesterday and already discussed, today we can see the passage and read it and discuss it. All the words and expressions that you are not familiar with. All right. So before I press the button, let me know if you can see my passage and if the sound is clear, let me know, okay? Can you see it?
Yes, teacher.
Okay, Carol, am I sharing it? Raquel is not here today, so.
Okay, teacher, I can see.
Okay, so just let me know if you can also hear it.
I don't listen to.
No?
No.
Me neither.
Okay. Minute. Okay. I'll start again. That's why I asked.
By many factors,
Okay.
including
Okay. Now you
radiation
can.
from the sun,
Yeah, but I'll
changes
start
in
again.
Yeah.
the Earth getting warmer
Okay.
by reworks.
Okay.
In 1975, a scientist named Wallace Wally Broecker wrote a paper in which he asked a simple question. Was the Earth getting warmer? When the paper was published, some of Broecker's colleagues laughed at him. Many of them believed that the world was actually cooling. Historically, there have been periods in which the Earth's temperature has slowly risen and cooled over thousands of years. This is a natural process that can be caused by many factors, including changes in radiation from the sun, changes in the Earth's orbit, and volcanic activity. However, climate change can also be caused by changes in the amount of certain gases in the atmosphere. Broecker had noticed that the amount of carbon dioxide, a colorless, odorless gas, was slowly building up. While some carbon dioxide is produced through natural processes, large quantities of it are also produced by humans. Carbon dioxide is generated in especially large amounts when we burn fossil fuels such as oil, coal, and natural gas. This burning happens when we drive cars, use electricity, and make certain products. When released into the atmosphere, carbon dioxide traps heat. Broecker reasoned that if people produced a lot of carbon dioxide, then enough heat would be trapped that the Earth would begin to warm. He called this global warming. Several decades later, many climate scientists agree with Broecker. The Earth is heating up, and humans are largely responsible. This warming process is often referred to as climate change. More carbon dioxide is being produced than ever before. Every year, humans produce about 8 billion metric tons of carbon. 2012 was the hottest year in recorded history, Recently, scientists estimated that more carbon dioxide exists in the atmosphere than has in over 3 million years. While scientists understand how climate change works, some of its effects are still difficult to predict. Some scientists expect an increase in so-called extreme weather events, such as hurricanes and floods. Others foresee a rise in levels of seawater. While exactly what changes will happen are unclear, Broker has warned that people should be prepared for some large disturbances. In an interview with The Guardian, a British newspaper in 2008, he compared the Earth's climate to a wild animal. Sometimes when provoked, the animal will react violently and unpredictably. If you're living with an angry beast, you shouldn't poke it with a sharp stick, he said. Why are scientists able to understand some phenomena, like climate change, in a general way, but aren't able to predict the changes they will have on the Earth? Part of the reason is because many large Earth systems involve feedback loops, processes that help amplify positive feedback loops or diminish negative feedback loops, certain changes. Feedback loops can occur in the climate system too. If the temperature of the Earth rises, it can change the environment so that it produces even more heat. There are a number of different ways in which this phenomenon occurs. Scientists who work in the Arctic, at the northern end of the Earth, have been reporting that every year, more and more floating sea ice melts. In the last 30 years, more than 1/3 of the ice that appears in the Arctic during the summer has melted away. This worries scientists because Arctic ice plays an important role in cooling the Earth, although not in the way you might think. While we add ice to our drinks to make them colder, Arctic sea ice cools the Earth in a different way. Ice, which is white-colored, reflects light. This means that much of the sunlight that hits ice bounces off and is sent right back to space. Reflecting light away helps keep the Earth cool. However, as the Earth heats up, ice begins to melt. As ice melts, this reveals more of the dark-colored land or ocean water, which doesn't reflect heat but absorbs it. So less light is reflected back into space, causing the climate's temperature to increase. As the world gets hotter, this causes the ice to melt even faster. This increase in temperature causes still more ice to melt, which causes the world to get hotter, etc. This is an example of a positive feedback loop in which heat produces more heat. Similarly, there are other climate systems that can get caught in feedback loops. There are many gases that, like carbon dioxide, contribute to global warming. Some of these gases are trapped in the frozen tundra across Alaska, Canada, Russia, and other northern lands. This soil, whose temperature is below freezing, is called permafrost. When permafrost melts, much of this gas is released into the atmosphere. This causes the atmosphere to warm up, which melts more permafrost, which heats up the atmosphere, etc. Again, a feedback loop ensues in which a warm climate leads to the creation of an even warmer climate. A more complex example of a similar phenomenon involves the Amazon rainforest. When temperatures rise, the rainforest experiences more droughts and wildfires. This causes more trees to burn down. Just as when humans burn fossil fuels, the burning of trees causes large amounts of carbon dioxide to be released into the world. Trees play two important roles in preventing global warming. They help absorb carbon dioxide, which prevents it from trapping heat in the atmosphere. And rainforest trees help pump water into the atmosphere. When trees burn down, less water is pumped into the atmosphere, which leads to less rainfall, which leads to more trees burning, which leads to more carbon dioxide being produced. These are both examples of positive feedback, but feedback can be negative too. When negative feedback occurs, an original effect is diminished. Both positive and negative feedback loops can occur in all kinds of Earth systems, not just in a system related to the climate. For example, the relationship between different species of animals is a kind of system as well. Periodically, the populations of certain animals will wax and wane. In some cases, the population of a species can become stuck in a negative feedback loop. This can occur if a predator becomes too powerful and its prey becomes too weak. For example, In the early 19th century, humans began hunting a species of bird known as passenger pigeons. Soon, fewer birds existed, which made it more difficult for the species to mate. As mating declined, fewer birds were born, which made it still more difficult for the birds. This created a negative feedback loop in which the population of the birds continued to fall until they are now extinct. While scientists understand some of how these feedback loops work, they lack a deep knowledge of them, making them extremely unpredictable. This is because, like any complex system, these feedback loops include many variables. Many of these systems are also interdependent, which means that many of these feedback loops affect each other. For example, when permafrost melts, it makes the whole world hotter, not just the area around the permafrost. And these changes are not just limited to temperature. Changes in the amount of rainfall an area receives can lead to changes in its atmosphere. This, in turn, can affect the Earth's temperature, which can affect how much ice melts, which can affect how much rain falls, and so on. So a small change to a very complex system can lead to very big consequences. This makes predicting the behavior of large systems incredibly difficult. Some skeptics about climate change point to this uncertainty as a way of casting doubt on whether the world is actually warming. However, being unable to predict the effects of climate change does not mean that it is not happening. Think back to Broca's analogy. If you poke a wild animal with a sharp stick, you may not be able to guess exactly how it will react. However, even if you don't know precisely what the animal will do, it may bite you or scratch you or just growl. It's still a very bad idea to provoke it. Scientists continue to debate exactly what happens as the Earth's temperature rises. Among the most popular ideas are that dry areas will become increasingly dry, while wet areas will become increasingly wet. Oceans, seas, and lakes will rise, and glaciers, ice caps, and snow-covered areas will become smaller. However, many climate scientists agree that a potential way of reducing the effects of climate change is to cut down the amount of carbon dioxide in the atmosphere.
Long, but very interesting. Exactly the last sentence. Is this what most countries are doing nowadays? Are they reducing, cutting down the amount of carbon dioxide in the atmosphere, or they are increasing it?
Now, for the pandemic, down, but usually increase.
Yes,
No?
yes, including the fact that the United States just left the treaty in which all countries promised to reduce the emission of carbon dioxide a lot by, I don't know if it was 2022 or something like that. And the United States just signed it out. They said they are not going to respect that. Understand? So that means, fuck, we are going to continue polluting, okay? We need America to be great again. We need to continue producing, okay?
Yeah.
So, well, I don't know if you notice any word or anything that you are not familiar with, but now we're going to read it and we can discuss, right? So, Claudia, could you start reading the first and the second paragraph for us, please? 1975. See,
Okay.
it's been a long time.
Okay. In 1975, a scientist named Wallace Wally Brocker wrote a paper in which he asked a simple question: was the Earth getting warmer? When the paper was published, some of Broca's colleagues laughed at him. Many of them believed that the world was actually cooling.
Yeah, in your opinion, the world is freezing, right?
But in 1975, it was a long time ago.
Yes, okay. Historically,
There have been periods in which the Earth's temperature has slowly risen and cooled
Yes.
over thousands of years. This is a natural process that can be caused by many factors, including changes in radiation from the sun, changes in the Earth's orbit, and volcanic activity. However, sorry.
Before you continue, is there any question about this part or no?
No.
No, I don't think so.
Good.
No.
That was a piece of cake, right? Okay, Isa, can you read the third paragraph, please?
Oh, it's a big one. However,
That's why I gave you only one.
thank you. However, climate change can also be caused by changes in the amount of certain gases in the atmosphere. Broker had noted that the amount of carbon dioxide,
Yeah.
a colorless, odorless gas, was slowly building up. While some carbon dioxide is produced through natural process, larger quantities of it are also produced by humans. Carbon dioxide
Yes, dioxide.
is generated in especially large amounts when we burn fossil fuels such as oil, coal, and natural gas. This burning happens when we drive cars, use electricity, and make certain products. When released into the atmosphere, carbon dioxide traps heat.
Heat is on. Okay.
Broker reasoned that if people produced a lot of carbon dioxide, then enough heat would be trapped that the earth would begin to warm. He called this global warming.
Yes. Yes, it's very easy to understand, maybe complex to solve the situation, but the point is, with all the emission of carbon dioxide, okay, this has created, because this gas is trapped into the atmosphere. It goes up, but it doesn't go out into the space. It's trapped by the atmosphere of the planet, understand? And what happens? Once it is trapped there, it avoids the reflection of the heat that comes from the sun. Because every day the earth is bombarded by the sun rays that keeps the earth warm, okay? And this heat usually heats and bounces, okay? But what happens? When it gets there, it's trapped and then bounces back. So it keeps going up and down, up and down, up and down. That's why the earth is getting warmer. It's a little complex, but this is exactly what is happening, okay? Any specific vocabulary question about this part? Marcos? No?
No.
No, Isa, Claudia, Carol?
No,
No.
it's okay.
No, everyone okay? Fabio, any problem or no?
I have one word. What means cold, teacher?
Do you know that black thing that we use to make a barbecue?
Yes, I know. Okay.
Okay. Certain I was going to say hydroelectrical plants, but if it's hydroelectrical plants, they use water. They don't burn coal. But in Brazil, there are many thermal plants. In thermal plants, there are many different kinds of plants used to produce electricity. Hydro, thermal, and nuclear. These are the most common. And then nowadays, of course, you have a lot of electricity produced by windmills, you know,
Yeah.
things like that, the eolic.
And
But yes, the thermal plants, Carol, they produce energy by burning coal in large quantities.
teacher,
Understand?
I saw a program and I don't know, I think in the Netflix, I don't know exactly where, and this program said that the dirt type of energy is the coal,
Yes.
and the first the country that have this type of energy is the Australia, and
Australia.
Australia, and almost all the energy in Australia is
Generated
by, yes, through the
thermal
coal.
plant. Yes,
Yeah.
thermal plants. Yes. Yeah, that's, and it's funny because every time the level of the water in our hydro plants is low, we can't produce as much electricity as we need. So we activate the power plants by burning coal. And the energy produced is much more expensive than the one produced in the hydro plants, understand?
Yeah.
Because you need to burn a lot of coal. Fabio, can you read the next paragraph for us, please? Several decades later.
Okay, teacher, I will try because my connection is not so good. But several decades later, many climate scientists agree with Broker. The Earth is heating up, and humans are largely responsible. This warming process is often referred to as a climate change. More carbon dioxide more carbon dioxide is being produced than ever before. Every year, humans produce about 8 billion metric tons of carbon. And 2012 was the
Hottest. The superlative of hot.
Hottest year in recorded history. Recently, scientists estimate that more carbon dioxide exists in the atmosphere than has in over 3 million years.
Okay. Any problem about this part or no?
No.
No.
Max, Carol, Érica.
No.
Tiago. No?
No.
Okie dokie. Max, could you please read the next paragraph for us? While scientists.
Okay. While scientists understand how climate change works, some of its effects are still difficult to predict. Some scientists expect an increase in so-called extreme weather events, such as hurricanes and floods. Hurricanes and floods. Other forces are rise in levels of seawater. While exactly what changes will happen are unclear, Broker has warned that people should be prepared for some large disturbances. In an interview with the Guardian abbreviation newspaper in 2008, he compared the Earth's climate toward animals. Sometimes when provoked, the animal will react violently and
Unpredictably. Okay. Any question about this part?
Floods.
Others foresee a rise.
Foresee? Érica, you're asking me that? I don't believe you don't know.
Really? I forgot.
No,
Yeah.
because this is a perfect synonym for the word that you love. Forecast, foresee, is the same.
Forecast is the same?
Yes, when you foresee, when you see in advance, when you forecast, it's the same. They are perfect synonyms.
Great, teacher.
And it
Yeah.
makes
And floods, teacher.
floods. Yes, floods.
Floods is when the water level of rivers and lakes they increase and they flood all the surrounding area. It's very common in São Paulo when it rains a lot. Large, vast areas of the city are flooded. Okay?
Okay.
In Rio too. Okay? Another question about this part or no?
No.
Okay. So, let me see. Tiago, can you read the next part, please? If you're living with an angry beast.
Okay. If you're living with an angry beast, you shouldn't poke it with a sharp stick, he said. Why are scientists able to understand some phenomena like climate
change
in a general way, but aren't able to predict the changes they will have on the Earth? Part of the reason is because many large Earth systems involve feedback loops, processes that help amplify positive feedback loops or diminish negative feedback loops, certain changes. May I continue?
Yeah, you finish this part.
Okay.
Feedback loops can occur.
Feedback loops can occur in the climate system climate system too. If the temperature of the Earth rises, it can change the environment so that it produces even more heat.
Okay. Any question about this part?
Oh.
No.
Understand what the guys...
Environment.
Beast.
I know the word, but I don't know the meaning.
You don't know what is beast? Really?
I don't know.
Like animal,
very wild animal.
Beauty and Beast. Claudia.
Yes.
Beauty and the Beast.
Very good.
Yes. The Beauty and the Beast. Okay.
Okay.
This is like my wife and me. Okay, the Beauty and the Beast, okay? Yeah, if you are living with an angry beast, you should not poke it with a sharp stick, understand? Because you never know how it will react, okay? It is interesting to understand what the guy means by feedback loops, you know? Like positive feedback loops or negative feedback loops. Understand this? It's a looping system, something that circles like a loop. Understand? When you have a positive feedback, it means the consequences are amplified. Understand? Like the more carbon dioxide is trapped into the atmosphere, the more the Earth will heat up. So this is a positive feedback loop. And if we planted lots, thousands, billions of trees, the trees would be able to absorb the carbon dioxide released in the atmosphere. And this would create a negative feedback loop because it would diminish the effects. Understand? Yes or no? Or too complex for you?
Yes.
Oh, teacher.
Yes, Carol.
I have difficulty to understand exactly the meaning when you say the trap in this way.
Yeah.
I understand, but I have difficulty to think in this meaning of this word in my mind. Understand my point?
Yes, to trap.
Because the
is
trap
when you-
is, yes, I understand the trap, but in the other meaning.
Okay, but it's practically the same. Let me see if I can do something different. Let me see. I will try. I will try. I'm not good at this. I'm not good. So let me see.
Oh my gosh, teacher, real draw.
Yes. Oh,
Go ahead, go
Got
ahead.
it.
what is this?
Got it.
This is a ball,
A
a
circle,
circle.
a loop.
Circle.
No, this is our planet, Earth.
Oh my god.
Oh, now I can see.
I
that.
knew it.
Oh, you need to use your imagination.
It's very similar.
Yes. What happens? Every day we send out, you see, we emit a lot of carbon dioxide, right?
Yeah.
Mm.
But the problem is that here we have the atmosphere around the planet Earth. Understand?
Mhm.
And the gases, Carol, they cannot go out into the space. They are trapped by the atmosphere.
Okay, okay. In the Portuguese, you say that in Portuguese, of course, the dioxide is rest in the earth. Understand? Rest?
My mind is not processing that in Portuguese. I'm sorry.
No problem, teacher.
No, it's trapped when it cannot go out.
Tá
Okay,
preso,
understood.
tá preso, ele tá preso.
Yes,
It
exactly.
can't go out, understand? And then what happens? We keep sending more gases, okay?
Okay,
And
teacher.
it creates like a layer here, okay?
Mm-hmm.
Of trapped gases. And the problem is, every day the sun sends a lot of energy.
This is amazing. This.
Oh. This is the sun rays coming to the earth. Usually, part of this energy that comes from the sun is absorbed, okay?
Okay.
So we have here like the continents, okay? Brazil, blah, blah, blah. We have here Europe, okay? We have here Africa, blah, blah, blah. Oh, Salvador is here, okay? Oh, see, Salvador Bay. And Recife is up here,
Ué,
Do you know the game you got?
yeah.
You are excellent player.
Okay, if you don't stop joking, I stop drawing, okay? I'm doing my best. Well, my fingers are magic, okay? I can't control with the mouse pad here. So what happened? The sun comes in, hits the earth, and part of it bounces back. Oh. Understand?
Mm-hmm.
The problem is here in the South Pole, South Pole and North Pole. When it was completely covered by ice, the white color would absorb the heat better. That's why when you go out wearing a black t-shirt, you absorb more heat because the black doesn't reflect the heat. The white does, understand? The black absorbs. And then what happens? The oceans, as they become larger, they absorb more heat. They don't bounce back anymore. Understand? Like it doesn't bounce back.
It's a greenhouse effect.
Yes, exactly. Greenhouse effect. Okay? Yes, because greenhouse is a place where you keep plants. And they use the term greenhouse because the sun comes in, but the sun cannot go out. Understand? So it keeps the plants in a good temperature inside.
The name is greenhouse.
Greenhouse
I
effect.
didn't know.
É, efeito estufa.
Yes,
I didn't know
greenhouse
that's
effect.
the name.
Yes. And the reason why is because of this. The energy that should bounce back into space, like here, it can't go out. It's trapped by the carbon dioxide layer that has been created around the Earth. Okay? Oh, this is a beautiful drawing. It's like a
Amazing.
two-year-old boy drawing. Okay?
Like your daughter.
Yes, but I rely on your imagination to understand. Okay?
I was taking a picture.
I think it's too late. Well, but if you send it to your psychiatrist to analyze
Thank
me,
you.
I will get very angry, okay?
No, it's okay.
Like, Mr. Shrink, this is the drawing that my English teacher did in our class. What do you think? The guy would say,
Wow.
I'm nuts, okay?
You're a good person.
You're better than me.
Okay, so,
Thank you.
okay, good. We are here. Who hasn't read yet? Say me. Who hasn't read yet? I forgot after that beautiful drawing. Fabio has read, Isa has read, Marcos has read. Carol, have you read? Yes. Erika, yes. Claudia, yes. Tiago, yes. So let's go back to Claudia then. Claudia, there are a number of different ways.
There are a number of different ways in which the phenomenon occurs. Scientists who work in the Arctic at the northern end of the Earth have been reporting that every year more and more floating sea ice melts. In the last 30 years, more than 1/3 of the ice that appears in the Arctic during the summer has melted away. Can I continue?
Yes, read one more. This is very
Okay. This worries scientists because Arctic ice plays an important role in cooling the Earth, although not in the way you might think. While we add ice to our drinks to make them colder, Arctic sea ice cools the Earth in a different way. Ice, which is white-colored, reflects light. This means that much of the sunlight that hits ice bounces off and descends right back to space. Reflecting light away helps keep the Earth cool.
This is what I was trying to show you. Okay? The guy is so complicated. Okay?
Now you got it.
They should just draw.
Yeah. Yeah. See, it was easier to draw it. Okay? Any question about this part or no?
Bounces off, teacher.
Is reflected.
Okay.
Okay? Carol, there is a fun expression. You can also use this. Maybe you have never heard, but it also exists in English, okay? It's a bouncing check. Okay?
What it means?
It's a check that you give me to pay for something. I deposit and boing. It bounces.
Okay.
Okay?
Okay.
It's a bouncing check. Okay? That's the idea. Part of the light should bounce off, be right back into the space, but it's getting trapped by the greenhouse effect, by this ozone layer that was, I don't know, this dioxide layer that was created there and destroyed the ozone layer. It's complicated. I understand a little bit. More than I should, I think. Tiago, can you read the next part? However,
as the Earth heats up, ice begins to melt. As ice melts, This reveals more of the darker colored land or ocean water, which doesn't reflect heat, but absorbs it. So, less light is reflected back into space, causing the climate change.
Climate, temperature
climate
to increase.
Temperature to increase. As the world gets hotter, this causes the ice to melt even faster. This increase in temperature causes still more ice to melt, which causes the world to get hotter, and etc. This is an example of a positive feedback loop in which heat produces more heat.
Yes, that's why it's positive, because it amplifies the heat. Understand? Any other question about this paragraph or no? No?
No.
Carol, that's yours. Similarly,
Similarly, there are other climate systems that can get caught in feedback loops. There are many gases that, like carbon dioxide, contribute to global warming. Some of these gases are trapped in the frozen gases.
It's not Z, gases.
Gases trapped in frozen tundra across Alaska, Canada, Russia, and other northern lands. This soil whose temperature is below freezing is called permafrost. When permafrost melts, much of these gases gas is released into the atmosphere. This causes the atmosphere to warm up, which melts more permafrost, which heats up the atmosphere, etc. Again, a feedback loop inches in which a warm climate leads to the creation of an even warmer climate.
Okay, ensues. Okay.
What means, teacher? I don't know.
It starts again.
Okay.
Probably you know the verb to sue.
Okay. Yeah.
Like sue me. Okay.
Yeah.
Ensues, it starts again. A feedback loop restarts, in which a warm climate leads to the creation of an even warmer climate. Okay. Is there any other question about this?
Tundra.
This is a kind of soil. Understand soil?
Yes.
Okay, that exists only in the north of the globe. North of Canada, Alaska, Russia, okay, Greenland. It's under the surface, you have this kind of soil, which they also call it permafrost. Understand? It contains, yes, it's the same name in Portuguese. Maybe you have never heard, but it's exactly the same name. It's a kind of soil which contains a lot of gas, including the gas that we use in the kitchen. For instance, Russia is one of the biggest producer and distributor of gas to Europe. Europe practically depends on the Russia gas. Canada also produces a lot, and this gas is exploited from this tundra, from the permafrost, understand? But, as I said, as it starts warming, it starts melting. And when it melts, it releases more gas into the atmosphere. Okay?
Okay.
All right.
All right.
Okie dokie. Okay. Since you are the youngest one, I'll give you the biggest one. Isa, read this for us to finish, please. We have already finished the class, but let's read one more.
A more complex example of a similar phenomenon involves the Amazon rainforest.
Yeah, Raquel is not here today because she's from there.
When temperatures rise, the rainforest experiences more droughts and wildfires. This causes more trees to burn down. Just as when humans burn fossil fuels, the burning of trees causes large amount of carbon dioxide to be released into the world.
Released
Into the world. Trees play two important roles in preventing global warming. They help to absorb the carbon dioxide, which prevents it from trapping heat into the atmosphere. And rainforest trees help pump water into the atmosphere. When trees burn down, less water is pumped into the atmosphere, which leads to less rainfall, which leads to more trees burning, which leads to more carbon dioxide being produced. Dioxide being produced. These are both examples of positive feedback, but feedback can be negative too. When negative feedback occurs, an original effect is diminished.
Okay. Any question about this part?
Droughts.
I'm sorry.
Droughts. More droughts and wildfires.
Droughts. Yeah, I was looking for a different word, but the pronunciation is drought. Drought is the opposite of flood. Flood is when vast amount of water covers an area. Drought is exactly the absence of water, you know?
Okay. And the pumpy water, help pump water.
Yes, to pump like on the farm where I live, many years ago, I had a water well, understand? So we just dug like 50 meters and we found a large reservoir of water underground. But it was necessary to bring that water into the surface. So it was necessary to install a machine called a pump to pump the water, understand?
Okay.
You can also pump like air into a tire, you know, of a car.
Okay.
All right. Another question?
No question.
Yeah. No. Have you seen the number of fires? Of course, there are some that are
Criminal.
I don't want to talk about, but the number of wildfires in the Amazon this year increased a lot.
Yeah.
Understand? And in Australia too, okay? Consequences of this, okay? Isa, just for your information, or Eric, I don't know who asked me, I was checking here, it's very funny. As I told you, permafrost, I use this in Portuguese, permafrost. But I wanted to know if there was a name for that in Portuguese. So I asked my friend beside me here if there was a name. Believe me, it's better to remember the name in English. You can say pergelisolo. Pergelisolo.
Permafrost is good.
Never heard about it.
Yes,
Pergelisolo.
I imagine a guy from Recife saying pergelisolo, something like this.
Peraí.
Pergelisolo with double S.
Pergelisolo.
But it says o permafrost, okay? It's used in English. And tundra, it's used in English. The same name, tundra.
Tundra
okay?
is the same.
Yeah, it's very easy to recognize a tundra area in Alaska, for example. It's a place without any trees. No trees grow. in a tundra. Understand? Just very short vegetation, no tall trees, no trees at all. That's typical of a tundra, okay?
Okay.
Excellent. We can call it for the night. We can stop here. Tomorrow we'll just finish reading and do the comprehension. If you have time, we just have a little more part to read, but it's already too late, okay? And then we'll do the comprehension and we'll finish this, okay?
Okay.
Have a wonderful
Good
evening. And
Thank
I
you,
see
teacher.
you guys
Thank you.
tomorrow.
Bye, guys.
Bye
Thank you,
bye.
teacher.
Bye-bye.
Have a good night.
You too. Thank you. Bye bye.
Bye bye.